Hello everyone, we almost going to end the section on time complexity. This is the final section. I have merged the last two sections, the recursive section and the amortized section. In total, there are 4 problems. We are going to solve them one by one. Let's look at the first problem. And here, basically, we are given a recursive function. I have already taught you the theory of recursive relations, recurrence relations, and how to solve them in my previous video. Please have a look at it once before watching this video. We are given a recursive function with a start and end. So we basically gave input of n, where n is between start to end. This range of numbers are the input for us. Now what are we doing? We are calculating the mid value, and we are either calling the left half or calling the right half or calling both. This is the worst case. We are calling both halves again. So we are asked to calculate worst case time complexity. So we'll consider the worst case, which is the last case. So how do you write the recurrence relation for this function? Initially, you are given a function of t of n, where n is the input. In this case, the input is in form of range, start to end, and it is being divided into halves, and subproblems are called. This is the recurrence relation. How do you write it for the worst case? For the worst case, we don't care about this. We only want this case. This is the worst case. In these two cases, only one of the function call is happening. But in this case, both function calls are happening. So this is the worst case. So how do you write the recurrence relation? The problem is being divided. The input is being divided into half. This is one half, and this is another half. Start to mid is one half, and mid to end is another half. So this will become t of n by 2 plus t of n by 2 plus t. This is constant time for these base conditions and everything else. So how can you write this? 2 times of t of n by 2 plus t. Just give me a minute. Yeah. And I think I have solved this recurrence relation in my previous video, but I'm solving it once again. Initially, the root will be t of n. Then how are you going to split it? You write the non-recursive part as root and the recursive part into its children, t of n by 2 and t of n by 2. And we follow the same procedure for these children also. This tree becomes c t of n by 4, t of n by 4, t of n by 4, t of n by 4. So this goes on like this. And where will it end? It ends when the input becomes 1. This is the last valid case. So if you see the base case, start greater than end, which means there is no input. The n is 0. That is the base case. And the last non-base case is when n is 1. Start is equal to end. So at t of 1, it ends, right? And we can write this as n by 2 power k. t of n by 2 power k. And when does n by 2 power k become 1? N by 2 power k is equal to 1, which gives us k is equal to log n. As we have already seen, k is log n, which means the height of the tree is log n. Now, just give me a minute. A second. I will take. Now see this. Now you have to calculate the sum of all nodes in this tree. And the first level contains only C, second level contains 2C, then 2 square C until 2 power k C, where k is log n. And this is a geometric progression, as you already know. C plus 2C plus 2 square C and so on, plus 2 power k C, where A is C, R is 2, and number of terms n is equal to k plus 1. And sum is A into C into R power n, 2 power k plus 1, k is log n plus 1 minus 1 by 2 minus 1. And this is equal to C into 2 power log n 2 power log n is nothing but nc, which gives us O of n finally. So the answer for this is big of n. Let's have a look at this. Yeah, this is big of n. Let's go to the second problem, which is here. Yeah, now look at this question. We are given a function with two parameters r and c, and each time either r is incrementing by 1 or c is incrementing by 1. No, both are getting incremented. So initially we'll be given, and base cases are when r is equal to minus 1, r is equal to number of rows minus 1, and c is equal to number of columns minus 1. Initially we will be given a function f of 0 comma 0. These are the values passed initially to us, and this can call f of 1 comma 0 and f of 0 comma 1. In this case r is incrementing by 1, and in this case c is incrementing by 1. And this will call again f of 1 comma 1, f of 0 comma 2, and this will call f of 2 comma 0, f of 1 comma 1, and this goes on like this. So let's visualize this problem. Here we are given a matrix. Initially we are here, to go here, and the leaves will be all f of r comma c. All leaves will be f of r comma c, because that's the base condition. So to go from here to here, how many steps will we take? This is a 3 by 3 matrix. How many steps will we take? You can either go from here, then here, and here, and then here. How many steps? How many steps did you take? There are 4 steps, which is nothing but r plus c minus 2. These many steps you have taken to get to the last bottom right column, bottom right cell. So now you probably might have guessed each level is equal to 1 step. We are making steps here. And how many steps does it take to get to the last cell, which is basically the height of the tree? How many steps does it take? This is r plus c minus 2. So the height of the tree is height of the tree is equal to r plus c minus 2. This is the height of the tree. Now let's calculate the time complexity. At each step we are doing constant work. So at the first level we did c work, and the second level 2c, then 2 square c, and so on until 2 power k c, where k is the number of levels on the tree, basically the height of the tree. So to sum all these up, c plus 2c plus 2 square c, and so on until 2 power k c. 2 power kc. This is a geometric progression with a is equal to c and r is equal to 2, n is equal to k plus 1. So what will be the sum? Sum is equal to c a into r power n minus 1 by 1 minus r minus 1 is equal to c into 2 power n is k plus 1, k is r plus c minus 2, which becomes r plus c minus 1 by r is 2. 2 minus 1 is 1. This is nothing but this is some constant into 2 power r plus c, by which we can finally conclude that O of order of this function is equal to, this is the order of 2 power r plus c. You eliminate the constants. This is how you solve this problem. And as you might not have noticed that each function call, these functions are repeatedly called. This is called here, and it is called here once again. And this point is very important to solve the next problem. Here it is. Here what it is doing is, when we are given r and c, but if we have already calculated the function value of r and c before, it will directly return that value. If we did not calculate this, it will calculate it using this recursive function, right? Now initially we are starting with 0, 0. we'll call 1 comma 0 and 0 comma 1 and so on, right? So in a matrix of R rows and C columns, this is 0 0, this is 0 1, 0 2, 0 3, 1 0, 2 2 0, 3 0, and we fill these values. Each value is calculated only once. After that, it will directly return that value. So how many values are we calculating finally? We are calculating every single cell of this matrix, isn't it? So what will be the time complexity of this function? This is R into C, big O of R into C. I hope you understood the point. And we'll finally go to the last problem, which is based on amortized time complexity. Now see this block of code. When you see it for the first time, you may feel that this is a loop inside loop. This will definitely be n square. You might have thought like this, but it is incorrect. Why? We will see. J is initialized to 0 initially, and then J is incremented in the inside loop until it becomes greater than or equal to n. J is incremented. Now, in the total process of execution, how many times would this instruction be executed in the worst case? Yeah, you guessed it right. In the total execution, it can take only, this instruction can be executed only n times at max, right? And how many times this loop will be executed? That is n times. N plus n is 2n, which gives us O of n time complexity. Why O of n, not O of n square? Because this loop is not executing every single time. J is not initialized every single time here. It was initialized at the start of the execution, and it is incremented until it becomes greater than or equal to n. So this instruction can only be executed at max for n times in the whole execution, and this for loop executes for another n times, right? So total 2n, which is order of n. I hope you got the point. We have successfully completed the time complexity section of Interviewbit. I hope you enjoyed these videos. Please do like and subscribe my channel, Algo Conqueror. Thank you very much.